What's going on, everybody? My name is Dana Harris, and once again, I'm bringing you more math jewels. So, we're continuing our series on the Common Core standards, and we're talking about the functions domain. And in this particular video, I'm going to explain one of the standards requires students to be able to compare the properties of two different functions that are given in two different forms. So what we have here is we have two functions. We have a function in equation form. We have a function in a table of values. And we're going to compare the properties. Specifically, as you can see, the question says which one has a lower rate of change. Now, in order to answer that, we need to find out what the rate of change is for both of these functions. And since they're represented two different ways, we may have to use two different methods or multiple methods to figure out what that rate of change is. So let's go ahead and get right into it. Now, the first one, when we look at the table of values, we need to understand that you can use the slope formula, but you don't necessarily have to. So just for the sake of knowing that information, I'm going to use the slope formula. Slope formula is M, because M represents is the variable that is used to represent slope or rate of change. So slope, even though we say rate of change, it's the same thing. That's what a lot of people are used to hearing. So M equals the change in the y coordinates between two ordered pairs divided by the change in x coordinates between two ordered pairs. Notice I didn't say x2 minus x1, I'm sorry, y2 minus y1 over x2 minus x1, because that's a formula, but it's important that you understand what's actually going on with this formula, okay? So it's the vertical change divided by the horizontal change, or a ratio of the vertical change to the horizontal change between two ordered pairs, okay? So also this is the second y coordinate minus the first y coordinate, which is going to give you the change in y, over the second x coordinate minus the first x coordinate, which is going to give you the change in x, okay? And that's going to give us our slope. So if we notice the change in y, 1, 1.5, 2, 2.5, tree, all right? So notice that the y coordinates are changing in increments of 0.5 or 1/2. So we're just going to say, let's use a decimal for the sake of the way the numbers are written. And notice now that the x coordinates are increasing in increments of 1. Okay? So, in this case, if we simplify this fraction, we will actually get, we can divide both of these by 0.5, and that will give us 1 over 2. So our rate of change, or our slope, in this case, in this particular function, M is equal to 1/2. All right? So, now, let's look at the next one. This particular equation is written in what we call slope-intercept form, okay? Slope-intercept form, okay? Slope-intercept form is very, very popular, and it looks like this. Y equals mx plus b. Now, what are all those variables mean? What do they mean? What do they mean? What do they mean? Okay, y is your y coordinate from an ordered pair. M is your slope, okay, or your rate of change. X is your x coordinate from an ordered pair. So once again, x is input, y is output, and then b is your y-intercept. That's where the graph crosses the y-axis, or I like to say the intercept is where the graph intersects the y-axis in this case, okay? So now, since it's already written in slope-intercept form, we know that the slope or rate of change is tree, all right? And then the y-intercept is -2, okay? So this is b. So we're trying to compare the slopes of these two, and notice this function has a slope of 1/2. This function has a slope of 3, or rate of change of tree. So as we can see, the answer to this particular question is this function, y equals 3x minus 2, has a, I'm sorry, I totally messed that up. it's asking which one has a lower rate of change. So this function right here has a lower rate of change because 1/2 is less than tree.